This video is going to look at functions and different properties of functions. So to begin with, we're going to look at domain and range. Domain is always talking about the x values. It's where on your graph you have x values. Right? The x value is always the independent variable. The range is always talking about the y values, where you have y values. Right? And the y value is always a dependent variable. The y value is always dependent on the x value. Alright, so for our first example, I've got 5 ordered pairs. Okay, ordered pairs, remember it's always x comma y. And this is one way of displaying points. Alright, we're going to see 2 more in a minute, but this is one way that a common way that you're going to see points displayed is as ordered pairs. So for these 5 ordered pairs, I want to find the domain and the range. So I want to tell where it has x values and where it has y values. Right, so the way I do that, I'm going to have a capital D for the domain, a capital R for the range, right, and then I'm going to use the squiggly brackets, or little curly brackets. Alright, the domain is x values. So I'm going to look at my x values. I've got 4, 2, 1, 9, and 4. Alright, all I'm going to do is list those in numerical order. So the smallest x value I have is a 1. Then it jumps to a 2. Then a 4. Well, then I got another 4, right? But I don't have to put it twice because I've already said that there's an x value at 4. It doesn't matter how many there are. I'm just telling you where there's an x value. So I don't have to include the second 4. And then the last one is the 9. And then I'm going to close my bracket. So remember, numerical order, and you don't have any repeats. Okay, you're just telling me what x values are being used. It doesn't matter how many. Okay, same thing for the range. Alright, but now I'm looking at the y value. So I got a 5, a 9, a 1, 1, and 3. Alright, so my smallest y value is a 1. Alright, then I have a second 1, but I'm not going to count it twice. I've already got it in there. Then it jumps to the 3, then the 5, and then the 9. So that's the domain and the range for this set of ordered pairs. And that's all you have to do. The other ways that you may see the ordered pairs could be a mapping or a table. Alright, a mapping or a table. So I'm going to use those same ordered pairs from the last example. I'm going to write them on here really quick. So we've got 4, 5, 2, 9, 1, 1, 9, 1, and 4, 3. Alright, I'm going to start with a table. Right? Most of you, probably all of you, have seen a table before. Okay, and it's just our typical XY table. So we got the X's on one side and the Y's on the other. Alright, what you have to keep in mind with an XY table is that as you read it left to right, okay, each row is one of your ordered pairs. Okay, now generally speaking, you're going to put your X column in numerical order. Okay, your x column is in numerical order. So I'm going to do the same thing we just did, right? My smallest x value was 1, then it jumped to 2, and then to 4, and I had 2 4s, and then a 9. Alright? Here you have to put all of your x values because you're listing every point that you have. Right? Now, I'm not going to do the same thing for my y's because then I change my ordered pairs. Right? So whatever my x is, I have to put the y that goes with it. So my 1 is with a 1. Right? My 2 is with a 9. One of my 4s is with a 3, and one of my 4s is with a 5. And then the 9 is with a 1. Alright, remember, each row is a point. So this 4, 3 has to be one of my coordinates. Alright, one of my ordered pairs. And that's all a table is. A mapping, it's a little different. Okay, it's similar to a table, right? And then it's similar to what we just did with the domain and the range. Okay, but it's a little different. Whenever you have a mapping, you're basically putting your domain and your range in columns. Alright, so remember the domain was just the x values, so I'm going to put them on the left side in numerical order. So I have 1, 2, 4, and 9. Okay, just like with domain, I only counted it once. Okay, no repeats. Then I'm going to put my y's on the other side. Okay, just like we did for the range. So I've got 1, I only count it once, and then it jumps to 3, 5, and 9. Alright, then a lot of times you're going to see a rectangle or a circle around these two sides, so I'll go ahead and do a circle. Okay, sometimes you may not see anything, but chances are you're going to see something surrounding those numbers. My great circles. Right? Now we have to somehow show the different ordered pairs that we have in this set. Right? Like the table, I had 5 rows, so you could easily see the 5 ordered pairs. Right? And then ordered pairs obviously show you the ordered pairs. So a mapping uses arrows. Alright, so we take the x and we point to the y. Alright, so for example, 1. 1 goes with 1, so I'm just going to draw an arrow over to 1. 2 goes with 9. 4 goes with 3 and 5, so I'm going to have 2 arrows coming from 4. And then 9 goes to 1, so we're going to have 2 arrows going to the 1. And that's it. That's all a mapping is. So a mapping takes an x and it points to the y that goes with it. So you have ordered pairs, mapping, and a table. Alright, now functions versus relations. Okay, they're two different things. Alright, a relation is any set of ordered pairs. Okay, so those 5 ordered pairs that we just worked with, that's a relation. Alright, any set of ordered pairs. A function is a special type of relation. Okay, it's a relation in which each element of the domain is paired with exactly one element of the range. All that means is that there's no repeating x values. Okay, so you have one x that goes to a y. Okay, you can't have that x going to 2 y's. Right? We can't have, like that example we just looked at. Remember how we had 2 4's in the domain? That means it is not a function. Okay, so that means no repeating x values. So I want to determine if these relations are functions. Okay, so the first one on the top left, that's ordered pairs. Okay, so all I'm going to do is look at my x values. I don't care about the y's, I just want to look at the x's. Okay, so I've got a 4, a 3, a 1, and a 5. None of them repeat, so this is a function. Okay, the second one, I've got a 2, I got a 3, I got a 2 again, right, and then I got a 1. Because that 2 repeats, this one cannot be a function. Alright, this top right one, this is a mapping. Okay, so it's a little trickier, you got to look at where your arrows go. So I've got a -2 going to a 4, a negative or a +2 to a 4, a 4 to a 16, a 5 to a 25, and a 6 to a 36. Okay, so I don't have but one arrow coming off of all of these numbers. Okay, that means that it is a function. Okay, if you were thinking about writing your ordered pairs for this, you'd have -2 4, 2 4, 4 16, 5 25, and 6 36. Alright, your x points to the y that it's with. Looking at these x values, none of them repeat, so this is a function. If you have 2 arrows coming from the same x, that's when you do not have a function. Alright, and the last one we have this table. So remember your table, each row is an ordered pair. So I'm just looking to see if I have repeating x's. So I have a -8, -1, 0, 1, 8. No repeating x's, so this is a function. Right? Another way of determining if something is a function or not is by looking at a vertical line test. Right? You use this whenever you have a graph. Okay, so if you're given a graph and not the ordered pairs or the mapping or the table, you're going to use the vertical line test. Okay, it's really easy. You've probably heard of it before. It's just that if any vertical line passes through no more than one point of the graph of a relation, then the relation is a function. Right? A lot of words, okay, but that means that it can only touch your graph one time when you take a vertical line and you move it across your graph. Alright? So for example, these red lines are a vertical line test. Okay, so the one on the left, if you move it from left to right, it's only going to touch it one time. Okay, it'll touch it at different places on the line, but it'll still only touch it one time. So it is a function. Okay, the one in the middle, same thing, from left to right, it's only going to touch it one time. Alright, the one on the far right, right here, okay, the line's over here, only going to touch it one. Look at that beautiful straight line. Okay, it's only going to touch it one time, until you get to this area. Okay, then I've got 1, 2, 3 times. Okay, so that means that one is not a function. Alright, so looking at these examples. Okay, example A. If I were to imagine taking a line, right, go there, keep going to the right, keep going to the right, all the way down, it's never going to touch more than one time. Alright, so that means that this one is a function. Now on your paper, you don't have to draw these little lines. You can just take your pencil or something and move it across. Alright, I just can't put a pencil on the screen. Alright, for example, B. Okay, put my line in and oh, I'm already touching it twice. Alright, that's more than once, so that means this is not a function. Alright, for example, C. Over here, it's only touching once, but then if I move over a little bit, I got 3 times. Alright, so that one is not a function. Okay, and then over here, nothing, only once, and then it's just going to keep going. So this one is also a function. Alright, the reason that the vertical line test works. Okay, remember, to be a function, you have to have no repeating x's. Right, so there can only be one x value for all your ordered pairs. Okay, you can't have repeating. Alright, now if you think about repeating x values, so let's say I've got 2, 2, and 2, 5. Alright, this would not be a function because I've got the same x value. It repeats. So if I sketch this graph, right, I go over 2, up 2, and then over 2, up 5. Okay, I know this is not a function because I have repeating x's. Looking at my graph, they line up on the same vertical line. Right, so if you're just looking at a graph, holding up a vertical line and moving it left to right, if your graph only touches it at one point anywhere on your graph, alright, that means it is a function. If it touches more than once, it is not a function because it has repeating x values. And that is it for this video.